Today we are going to learn our fourth and final way to solve quadratics. So we learned to solve by factoring, and I said that way is actually kind of my favorite way, but a problem with factoring is it doesn't work every single time. I think it's very clean when it does work, but it doesn't always work. We learned to solve by square roots. Again, a pretty clean way, but it doesn't work every time. Yesterday we learned to solve by completing the square. It does work every time, but it can get very messy. We avoided, actually, I didn't assign any of the problems where it gets really super messy, but if we have that coefficient of x squared and we have to divide everything by it and it doesn't divide evenly, then we get a whole lot of fractions we're working with. So today we're going to learn a final way that does work every single time. Arithmetically, it can get pretty gross. You would want a calculator to be working this out most of the time. But it does work every single time, and it's called the quadratic formula. The quadratic formula is this big formula, which must be memorized. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. It must be memorized, so to help you do that, we tend to memorize things best when they are put to music.
Oh, yeah.
So I have for you an extremely obnoxious song, which will get stuck in your head and help you learn this song.
Hi, boys and girls. Are you ready to learn the quadratic formula song? Come on! X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Isn't this fun? This is great.
That was awesome.
Let's try it again. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Let's do that again. Let's try and make it a little bit different. I don't know. Maybe a little rockish. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Come on. Maybe we can sing it a little bit faster. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. That was fun. Let's try it a little bit slower. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Oh, that was so nice, so sweet. Let's just sing it one more time. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Divided by 2a.
Okay, so I promised it would be annoying, and I hope it gets stuck in your head on test day anyway, because you do have to have that memorized.
I'm sorry,
So,
we cannot do this.
This
without
video
moments.
isn't for you guys.
We can't.
Take applied math if you want to watch Big Bang Theory. All right, so we are going to use that formula to solve problems. Our first step is we need our equation in standard form, which means we need everything on one side and just 0 on the other, just like we did for factoring. So we will subtract the 5 over so that everything is on the same side. Then A is the coefficient of x squared, B is the coefficient of x, and C is the constant. And make sure that you tie a negative to the number that follows it. So C is negative 5. C is not just 5.
Wait, what was the A, B, and C again?
A is in front of x squared. Yeah, my x is disappeared. So A is the coefficient of x squared, B is the coefficient of x, and C is the constant. Then we just want to plug this into the formula. So the formula is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. I can tell you, I learned this formula in probably like 1996, and I just heard this song maybe like 5 years ago, and now I can't say the quadratic formula without hearing that song. Like, that's how annoying it is. I knew the formula before I knew the song, and still the song has like permeated my idea of the formula. But hopefully that'll help you then learn it for the test. You want to work out what's under the square root first and using your order of operations. So square the 1, multiply all the stuff together, and then add it together. So that gives 1 plus 40. And on the bottom I get 4. So that gives me x equals negative 1 plus or minus the square root of 41 over 4. We want to simplify square roots when possible. Is there any perfect square that goes into 41? 41 is actually prime, so nothing goes into 41. So that's our answer.
Wow.
I have a question.
Yes.
What if B is like a negative, or like a negative number in the equation?
That's okay.
So would it still be negative?
It'd be negative b, so the negative then.
So it would still be a negative.
No, you'd have a negative. We'll get an example like that.
How did you get the squared? Oh, 1. 1 squared is just 1.
Yep. You can use your calculator to evaluate arithmetic, but just don't plug the whole thing in there because we want an exact answer. And if you start plugging in the square roots and stuff, that's just going to give us an approximation of the answer. But everything that's under the square root, you could type into your calculator and get what that is. I know there are many calculators that have formulas on them, like programs to run the formula, and all you have to do is type in the numbers, and it's beautiful, and it spits out the answer. Most of those will spit out the answer in decimal form, so that would be no good. Some of them will actually spit it out in this form. However, that's still not going to do you any good on the test, because on the test, I'm going to only give credit for problems where work is shown, since the directions for each problem will tell you a specific way to solve it, either by factoring or square roots or completing the square quadratic formula. I need to see the work to know that that is the method you're using. So if you are blessed to have one of those programs in your calculator, you could use it to check your answers, but don't begin to rely too heavily on it because that will not do well to prepare you for the test. Right, so in this one we've got stuff on both sides. So our first step is we need to get everything together on one side of the equation. It does not matter which side. So I will move everything over to the left side. Then A is what is in front of x squared. B is what is in front of x. And C is the constant. So then we're ready to plug into our formula. X equals negative b plus or minus square root of b squared minus 4ac divided by 2a.
Why'd you do the negative and by the -6?
The formula is negative b,
Oh, yeah.
so, and then b is already negative itself. So that double negative gives us a positive out there. Be careful that when you square a negative, squaring that -6 gives positive 36 minus 4 times 1 times 9, which is 36. So I get 0 in there. We froze. We'll see if it catches up. Over 2. Then square root of 0 is 0, so this really just turns into 6 over 2, and our answer is 3. When you get a really nice clean number as your answer, that means this problem was actually factorable, which in my preference would have been a faster way of solving it. But regardless, follow your directions and solve it the way that it says to solve it. But know that if you get a nice clean answer, that means it really was factorable from the beginning.
Is all the stuff inside the square root equal 0?
Yep. 6. The -6 squared is 36, and then 4 times 1 times 9 is 36. So 36 minus 36. In this one, we have stuff on both sides. We can get it together on either side, and it really doesn't matter which way you bring it. You'll get the same answer either way. Then when we factored, it's really helpful to have a positive a squared, because it's easier to factor that way. But when you're doing the quadratic formula, it doesn't really matter whether that a value is positive or negative. So for the way that I moved it, I have a is -1, b is 2, and c is -2. I plug it in. X equals -b plus or minus square root of b squared minus 4ac divided by 2a. And I begin evaluating inside of that square root. I get 4. 3 negatives make a minus, so I get 4 minus 8, which is -4. On the bottom, I get -2. What is the square root of -4? 2i. Square root of 4 is 2, and the square root of a negative gives us an I. We learned when we were studying our imaginaries that when we have something that looks like this with 2 things on the top and only 1 thing on the bottom, we can split them up and divide each part of the top by the bottom. And that's what we're going to do here for our final answer. So we're going to have -2 over -2 plus or minus 2i over -2. Which gives 1 plus or minus, technically plus or minus -i, but that plus or minus kind of absorbs any negatives into it. So we don't need to worry about that.
How'd that I get there?
Square root of a -4, square root of a negative gives us an I.
But if it was like a -7, you would still keep the square root.
Yes, if I couldn't take the square root of it, I would still keep the square root there, but I would put the I. Yep, so square root of -7 would be square root of 7i.
How'd you get the 1?
Reducing, so I divided that -2 that's on the bottom into each part of the top, like we learned when we were learning how to divide imaginaries. And so I get -2 over -2, which is 1, and then 2 over -2. So if you have one thing on your denominator and things we can divide it into on the top, we want to do that. This one has stuff on both sides, so I'd begin by subtracting that 35 over. Gives me an A of 3, a B of 8, and a C of negative 35. And we'll plug in the formula. X equals negative B plus or minus square root of B squared minus 4AC divided by 2A. The problems so far have had small enough numbers that I was able to calculate what was under the square root on my own. This one, you guys know arithmetic is not my strong point. These numbers just got too big for me and I can't do this on my own in my head anymore. So I would grab a calculator and just type all that stuff in that's underneath the square root, and that gives me 484. 484 is a very large number to have underneath a square root, so I would think it probably simplifies. The first thing I would do is check to see if it's actually a perfect square, because maybe it is. And then if it's not, I would look for perfect squares that divide into it. So if we take the square root of 484, what do we get? 22. It is actually a perfect square. So then we want to actually evaluate this problem. There are no imaginaries, there are no square roots left. Everything left is a nice, clean, integer, real number. So we want to actually do the two separate arithmetic problems that this says. It says negative 8 plus 22 divided by 6, which gives 14 over 6, or 7 over 3. And it says negative 8 minus 22 over 6, which is negative 5. So if you end up with all nice, clean, integer values, we actually want to separate that plus and minus and do them individually. We want to do the plus on the top, and then divide out, and do the minus, and then divide out, if they are all nice, clean, integer values. Questions?
Those are our answers.
So those are our two answers, the 7/3 and negative 5. The last part of our notes here today is about something called the discriminant. Catch that. Strange. There we go. The discriminant is b squared minus 4ac, which probably sounds familiar because that's what was under the square root. It is called the discriminant because it discriminates. It tells us the types of solutions that we are going to have to our problem. If that discriminant is positive, then that means in our quadratic formula we would end up having plus or minus the square root of something. So that gives us two answers, and they are both real answers because we had plus or minus the square root of a positive number. So if that discriminant is positive, we get two real solutions. If that discriminant equals 0, then we have plus or minus 0, which is really no difference at all, and we end up with only one real solution. We had that happen in our second example. If that discriminant is negative, we would end up taking the square root of a negative number, which is an imaginary then. We would have plus or minus an imaginary. So whether the discriminant is positive, 0, or negative can tell us about the types of solutions that we will have. If our discriminant is positive, we get two reals. Negative, we get two imaginaries. 0, we get just one real solution. The discriminant is not a way to solve quadratic equations. It doesn't tell us what our answers are. It just tells us what kind of answers we have. This means something about the graph. If we have two real solutions, solutions are places that the parabola, we learned when we learned how to graph quadratics that they were parabolas. Solutions are places where the parabola crosses the x-axis. So if that discriminant is positive, that means our graph could look something like this. Okay? It could also maybe look something like this. Okay? But somehow it's crossing twice. If that discriminant is 0, that means it only touches the x-axis one time, which means it just hits it and bounces right off. And that one solution would be that one place that it's touching the x-axis. And if that discriminant is negative, that means we have no places that it really crosses the x-axis. Our solutions are only imaginary. Okay? So knowing about the discriminant can tell us what our graph looks like. It does not tell us the solutions, though. It just tells us the kinds of solutions. A lot of students will be like, oh, well, that's quicker than doing the whole formula. I'll just do that. Okay? It doesn't give you the answers. It just gives you your types of answers. So for this one, we need it in standard form still. So we know what our A, B, and C are. A is 1, B is -6, C is 10, and we do the discriminant, just the b squared minus 4ac part. So it's -6 squared minus 4 times 1 times 10, which is -4. A negative discriminant means that I have two imaginary solutions. Okay, so some of your problems will just say, determine the number and type of solutions. How many solutions do we have, and are they real or imaginary? Then you can use the discriminant. If the problem says solve, do not use the discriminant. The discriminant does not solve it, it just tells us about our solutions. This one is not in standard form, so I would need to begin by adding 9 to both sides to get it in standard form. Then A is 1, B is -6, and C is 9. So our discriminant, b squared minus 4ac, -6 squared minus 4 times 1 times 9, which is 36 minus 36 or 0. So that means I have one real solution.
Do you do the square root of all that? or
Nope.
You just do the
Just what's under the square root. Our last one again is not standard form, so I need to begin by adding that 4 over. A is 1, B is -6, and C is 4. So b squared minus 4ac. -6 squared minus 4 times 1 times 4, which is 20. A positive discriminant means that I have two real solutions.
So in our homework, that's going to be our answer.
Yep, you'll actually want to give the discriminant as well, so I would want to know both of those pieces of information.
And then we don't have to solve it.
On some of them. If it says give the number and type of solutions, then you don't have to solve it. If it says solve, then we want to do the whole quadratic formula and solve that out. Your homework is as printed here, plus for honors 75 and 78.